Hello. So today I thought I would explore the integration between Java and Redis. Redis is well known to everybody as a cache, an in-memory cache to improve the performance of your requests, potentially caching data, so you don't have to do a round trip to the database every time. But it's increased its feature set over the years, and I thought I would go and take a look and see what new features there are in there now. So I think in this first lesson, or in this first episode, we'll just set up a basic Spring Boot application, create a connection to Redis, and then just test the standard caching features, get set value type of thing. And then from that framework, we'll explore the documentation and see what other interesting things we can find, and how we can test those features. Okay, so let's get started. So I did do a bit of preparation before this, just to make sure that I have everything on my computer and so on. But I'll take you through the steps now. So the first step, when starting a Spring Boot project, is to go to the Spring Initializer. Then you can choose the type of project build system you need. I'll be using Gradle Groovy. I think all three are good choices. Depends on your preferences. I'll be using Java. I would say Java or Kotlin are both good choices. I've not done too many things in Groovy for many years now, but if you like Groovy, that's fine as well for something like this. Then Spring Boot will choose the latest stable version, 4.4.1, and then you can set up a group and artifact name however you want. I'll be using comms mount on tech architecture or something like that. You can set up the name. I'll be using Java Redis demo. You can type a description and the package name, which should sort of echo your group. And we'll be wanting to package as a jar. I like to store configuration in YAML. It's a little bit more structured than properties files. I think I'll be using Java 21 for this project. Then dependencies, I think I'll only be using, at this stage, I'll only be adding web, so Spring Web, just so that we can create our RESTful endpoints with Spring MVC. I'll be adding the Redis dependencies later directly into the Gradle file, so that just lets me do things a step at a time. And then once you've filled out those things, depending on your own needs, you can click the generate button and it'll download a zip file, which will be a starter project for your Spring Boot project. Okay, so let's move over and see what that looks like. So I'm using IntelliJ IDE, and so the starter structure that we get from downloading from the Spring Initializer page is looks like this. So we have a main class. This is the entry point. Fundamentally, it runs the Spring application, says that configuration needs to be found automatically. That says it should find controllers and services, So we've also got in this resources folder, the static and templates resources folders are empty, but there is an application YAML, and currently this just has the name of the application in it, which is Java Redis. There is a test package. Now I think it'd be very interesting to do a video on different testing techniques, but I'm not going to focus on that in this video to keep it short. Other than that, we have our Gradle build file, which is build.gradle, and as you can see from the Spring initializer, it's given us the springboot WebMVC dependencies and the test dependencies. So there's enough here that we can run the application, and previously I set up a run configuration, which I called run application, and this simply just uses Java 21 to run the main entry point there. So if we can run it just to make sure that all the dependencies are available and that it compiles and that there's no issues. But don't expect any exciting features because we haven't written anything yet. Okay, Spring takes its time to start up, but we get the Spring splash message, and then we have a Tomcat starting on 8080, port 8080, and therefore we should be able to go back to our browser, and if we go to localhost 8080, we'll get the white label error page, which basically means that it can reach the server, but there's nothing there. So, or at least there's nothing where we're looking. And at the moment, as we've not developed anything, we just get the white label error page. Okay, so that's step one. So, how should we proceed? So, the next thing I want to do is to create a simple Docker Compose file so that we can run Redis locally. I could install Redis on my machine directly, but being able to associate a particular Redis configuration, Redis version, and so forth with a project is really useful. And as it's a simple YAML file, we can check it into the project, and that way other developers, if they look at this project, can run the project in the same manner and have exactly the same configuration as us. Right, so give me a second and I'll just add in that file. So here I've prepared a very bare bones Docker Compose YAML file, and what this does is it defines a service which is based on the Redis official image, using on top of the Alpine Linux image, and it exposes the default port 6379 to the world, to my computer at least, and it runs the Redis server with this command line. And it passes in this password as it sets this password as the required connection credential in order to connect to the instance. And then in volumes here, we're mapping the internal /data folder data path to cache, which is defined as a local volume on this on my computer. So next we're going to add in our Redis dependencies. So I'm going to use the Redis library along with Spring Boot's Redis data integration. Let's first add these into the build Gradle, and also we can add in the configuration into our application configuration YAML. So starting with the build.gradle, we add in this Redis client, and we add in the Spring Boot data Redis dependency as well. And then in resources, we have an application YAML, and so we're adding in this configuration here. So these are just values which will be available to us within the code base through the value annotations. And so these values are Spring Redis host, Spring Redis port, Spring Redis password, Spring Redis database. So these are the credentials. This is the password that we actually set in the Docker Compose file. So it ends with T81. So that's given us those dependencies. Let's just make sure everything still compiles, and then we'll start working on the application logic. Okay, so for the application logic, the first thing we want to do is to set up a Redis configuration class, basically just to read these values out of the application YAML and to create a new Redis pool. And that Redis pool will be available as a bean to the rest of the application. So let's give me a few minutes. I'll go and do that. Okay, so I've created a simple configuration class, and we can see what happens here. We have we've annotated it as configuration, which means that any value annotations inside it will have their values, the values of those variables or parameters injected with the correct values from the application YAML. So then we're creating a bean. So this bean method is annotated with these value annotations, and you can see the host is Spring Redis host. So what this will mean is that when we tell Spring that we want a Redis pool bean or a Redis pool instance, by, for example, saying in a constructor that we need it to be auto-wired with a Redis pool, Spring will have discovered this configuration class. It will have seen it's annotated with a bean, that it returns the required Redis pool. It then looks at the parameters needed to call this function, or this method, sorry, and it sees they've all got value annotations on them, and so it can go off to some source of configuration, which in this case is going to be the default application YAML, and it'll pull in those values, and then it can call this Redis pool method, and that's all that we need in order to create a new Redis pool instance and return it. And then the Spring Boot will be able to take that instance and inject it, auto-wire it wherever is needed throughout the application. Okay, so the next thing we want to do is to set up a service. So the service will use this configuration, use this Redis pool instance or this Redis pool bean, and it'll expose. So if we and it'll expose the features on that, or the functions on that object. We want to wrap it in a service because that allows us to do things like error handling, do things like specific application logic, logging, potentially other things. So just giving direct access to the Redis instance isn't really what we would normally do. So we'll wrap that instance into a service class, which lets us add our own layer of logging, testing, business logic on top of the basic Redis functionality. So give me a few seconds to do that. So I brought in this service class. So I've created a new package for services, and what happens on construction, we've got this annotated with auto-wired to bring in a Redis pool. So this Redis pool is the Redis pool that we created over here in the configuration class. And so when we say at the points in the application that we want this Redis pool connection service, the Spring will try to create an instance of it, and we'll see that there's a requirement for it to have a Redis pool, and so it finds that there's a Redis pool bean already defined here in Redis configuration, and so it calls that with a configuration value, passes that instance back, and uses that instance to instantiate this pool service. So I should say that I'm not using as many interfaces as I normally would. Typically, I would consider creating an interface for this class, but as this is just a demo, I don't see that it brings too much clarity to the discussion. I think that discussing why I put an interface in here in production work is maybe a discussion for another video. So also we can see, so within this class we've got the basic functionality of set value with expiry. This sets a time to live for how long that that key value pair will stay in Redis's cache, and then of course get value and a test for the existence of a key in the cache. And we're accessing the Redis API by using this get resource, and this returns a closable, so we can use this try with resources structure. So if there's any errors, we can ensure that the resource is closed if needed. So we can ensure that basically any time this method empties, we will call the close on this Redis pool resource. Okay, so now the next phase is to create a new controller package, and then a controller which will call these methods, and we'll auto wire in our Redis connection pool, and the controller will allow us to have a basic web test endpoint where we can try to set values and retrieve values, and exercise these features. Give me a while and I'll put in that test control. So I've created this Redis test controller, which exposes the key caching functions. So it's annotated as a REST controller, and this means that when we run the application, Spring Boot will find this controller, understand that it's a set of endpoints, web endpoints, and will route any requests, suitable requests, through to these methods that are annotated with request mapping types. It's got a private final variable called Redis pool, and this receives the auto-wired Redis connection pool service that we defined in the last step. Then we have a couple of methods for setting and getting values in the cache. So the set value obviously needs a post method, and it consumes application form URL encoded values. So we'll need to use either Postman or curl to call this, or set up a form on a web page, I suppose, or call it from JavaScript, or any number of other ways. But I'll be either using Postman or curl. And then the get mapping is just a get request, which takes the key in the path and then calls the Redis pool to get the value associated with that key. So if we run this now, so we run this, and now it's listening on port 8080. So we should be able to experiment with some of these endpoints. So we have one here that says cache /cache/key. So let's try this out, bearing in mind that we haven't actually set anything in the cache yet. Cache / let's call it cats. Okay. All right. Okay. So so we've called this, and we've got a 500 error back. So that means internal server error. And the exception that we have on the in the console is that we are unable to connect to Redis. Now, the reason why we're unable to connect to Redis is because we haven't run Redis. So I'm going to use the Docker Compose file that we created earlier. And locally on this machine, I have Podman installed. So instead of typing docker-compose up, I just type Podman compose up. Okay, that looks like it's running. So let's try this again. Okay, so this time no error, but also no value. And I would predict that in the network tab, we should see a 200. So it is successful, it just didn't find anything. $200, but it just returns an empty document. So let's go ahead and put something in the cache for this key. So I'm going to say, so I've created a curl request here, which posts form encoded data, URL encoded data, and I'm going to specify the key, which is a named parameter here, request parameter there, and we're using cats as our key value, and we'll say kittens as our value. So now if we go over to here, we can call cats, and we get kittens as a response. Okay, so we can implement maybe one more method here. So we have this Boolean exists. It's probably a good idea to implement that. So I'm just going to make that another get mapping. Obviously, we need to maybe we could say cache/exists. So currently cache/exists should give us a 404. But if I rebuild this, running on port 8080, okay, so I've put the get mapping on there, but I haven't specified the path variable, so that's going to be necessary because it comes in here, and because there's no mapping for the path variable, this is decided to be null, and so we're asking Redis whether a null key exists. So, and we get a true back. Okay, so if we did, for example, goat, we would get a false. Okay, so that concludes the first episode in this series on exploring Redis features. This is just the using the most basic feature of Redis, setting something into a cache and getting it back out of it again. But we can use this framework as a building block for exploring more exciting features later on. If there's any other features that you'd particularly like me to explore, I'm happy to take requests, and we can look through them in order of preference for people who are watching this. Otherwise, I'll work through the features in my own personal order of preference. Okay, thank you very much, and I'll leave it right there. Thank you.